The purpose of this video is to go over the concept of conditional probability. So we're going to do that by example. We're going to ask ourselves, what's the probability that a tree is a pine conditional upon it being tall? Another way to express that is, what's the probability of a tree being pine given that it's tall? Or equivalently, we're saying that we know the tree is tall. We know the tree is tall. What's the probability that it's a pine? And we're going to answer that question by using an example, and we're going to start off with this table of counts that has the trees cross-categorized according to species and according to height class. So the question is, what's the probability of a tree being a pine conditional upon it being tall? We know the tree is tall. We know the tree is tall, and so therefore we can ignore this row and focus only on the tall trees. There's 450 trees, 100 of which are pine, and therefore, given that the tree is tall, the probability of it being a pine is 100 divided by 450, which is equal to 0.22. Now, if we scoot down this table of probabilities, these are, of course, a mirror image of the table of counts with the values divided by 1,000. So we can get the same answer here by dividing the 0.10 by the 0.45 is also going to give us the 0.22. But what are we doing here? Well, what we're doing is we're getting the conditional probability of a tree being a pine conditional upon the fact that it's tall. And this vertical line stands for conditionality, or the word given. So the conditional probability of a tree being a pine given that it's tall is going to be equal to this thing divided by that thing. What's this? This is the joint probability of a tree simultaneously being pine and tall. And this is the marginal probability that a tree is tall. So now let's think about what would be the conditional probability of a tree being tall given that it's a pine. Well, if we come back here to the counts, what we'd say is, okay, we know that it's a pine. There's 150 trees that are pine, 100 of which are tall, and so therefore the conditional probability of it being tall given that it's a pine is going to be equal to 100 over 150. So if we come down here to our table of probabilities, what we're saying is, if we think about the probability of a tree being tall given that it's a pine, we're going to again begin with the joint probability that it's pine and tall, because we're operating in this column of pine trees, but now we're going to divide it by the marginal probability of it being a pine. So I'm going to say the conditional probability of it being tall given that it's pine is going to be, once again, the joint probability of it pine and tall, now divided by the marginal probability that it is a pine. There's another way to think about this. What is the joint probability that a tree is simultaneously pine and tall? Well, we'll just rearrange this thing and see that that's going to be equal to the conditional probability that it's pine given tall times the marginal probability that it's tall. And this is an interesting way to think about this relationship, because what we're saying is that in order for a tree to simultaneously be both pine and tall, first of all, it has to be tall, and then it has to be pine given that it's tall. But we can also say that the probability of it being tall and pine, if you use the same analogy, is going to be equal to the probability that it's tall given pine times the probability that it's a pine. These two things are essentially doing the same sort of thing. But if we consider this thing and this thing, consider these two things, they're equal, right? The fact that the probability of a tree simultaneously being pine and tall is the same thing as the probability of a tree being simultaneously tall and pine. So if these two things are equal, then these two things are also equal, and we can rearrange the equality of these two things in a couple of ways. One is to say that the conditional probability of a tree being a pine, given that it's tall, is going to be equal to the conditional probability that it's tall, given it's a pine, multiplied by the marginal probability that it's a pine, divided by the marginal probability that it's tall. Or, look at it another way, the conditional probability that it's tall, given that it's pine, is going to be equal to the conditional probability that it's pine, given that it's tall, multiplied by the marginal probability that it's tall, and divided by the marginal probability that it's a pine. And the reason these two things are important is that these two things are Bayes' theorem. And if we want to, we can express this in a more general way. Probability of S given H, probability of H given S, times probability of S, probability of H, or so, once again, Bayes' theorem in a more general format. So, just as a summary, joint, marginal, conditional probabilities. Where are they found? The joints are found in the body of the table. The marginal probabilities are found in the margins. The conditional probabilities, they're arrived at by calculations. You can't see them in the table, but if I want the conditional probability of a tree being a pine, given that it's tall, I take the joint probability that it's pine and tall and divide by the marginal probability that it's tall. In terms of the way we would represent, or the keywords, and. So this value of 0.15 is the probability the tree is simultaneously spruce and tall. For the marginal, this idea of overall, this 0.45 is the overall probability that the tree is tall. And the idea of conditional, once again, conditional probability of it being pine, given that it's tall, is arrived at calculation. The 0.10 divided by the 0.45. Here's how we represent those things. The symbol here is a comma. There's no symbol here, and the symbol here is this vertical line that can be read as given. In terms of the calculation, there actually, for the joint, there is no calculation. The raw data are found in the body of the table. You don't need to calculate these. And the whole idea is that this is the foundational, this is the basic. Starting from here, we can calculate the marginal, we can calculate the conditional, but we cannot go in the opposite direction. So we start off from the raw data and we calculate the marginal probabilities. So, for example, the marginal probability of the tree being a pine tree is by taking the combination of the joints, the pine and some sort of height class, and summing over the two height classes. And again, as we've seen, the conditional probability of a tree being pine, given that it's tall, was arrived at by taking the joint probability of it being pine and tall and dividing by the marginal probability that it's tall. And here we just see these specific examples given in a more general way. So I got to admit, this stuff here isn't the most fascinating stuff in the world, but again, to understand Bayesian statistics, it's important to understand Bayes' theorem. And in order to understand Bayes' theorem, it's really important to put the effort into understanding this stuff here.